Hello and welcome to yet another past paper walkthrough. Now in this video, we're going to be looking at the Further Pure Maths 1 paper for October-November 2022. So that's paper 11. Let's get right into it. All right, so we're starting with question number 1, and it says, the cubic equation x cubed plus bx squared plus d equal to 0 has roots alpha, beta, gamma, where alpha is equal to beta and d is not equal to 0. So on part A, show that 4b cubed plus 27d is equal to 0. All right. So in this particular case, we have been given this cubic polynomial equation. And basically, what we need to know is the sum of roots of this cubic polynomial equation. And the sum of roots should be b, actually minus b over 1. So that's minus b. Then we also need to know what the sum of product of pairs is. So sum of product of pairs is actually 0 because we do not have a term in x here. Then the product of roots, alpha, beta, gamma, for this equation should be minus d over the coefficient of x cubed. So it's basically minus d. So we now have these three important things that we're going to need. All right. Now, let us make use of this information. All right. Let's start with the fact that the sum of roots is minus b. What that means is alpha plus beta plus gamma is equal to minus b. But we have been told that alpha is equal to beta. So I'll say here, since alpha is equal to beta, it therefore means that for beta, I'll put alpha, which will make it 2 alpha plus gamma is equal to minus b. All right. And I'm just going to make gamma the subject here so that we have minus b minus 2 alpha for gamma here. All right. So let's leave this where it is. So that's equation 1. We are now going on to the fact that the sum of product pairs is 0. Okay. So I'll say here alpha beta plus beta gamma plus alpha gamma should be equal to 0. But making use of this fact, okay, I'll say since alpha is equal to beta, it means that here, where there's beta, I'll put alpha, so it becomes alpha squared. And that's going to be plus beta gamma. For beta, I'll put alpha again, since they're equal. So it'll be alpha gamma plus alpha gamma that's already there. So basically that's going to be 2 alpha gamma. Okay, so say plus 2 alpha gamma is equal to 0. All right. Now, since already from equation 1, we now have gamma in terms of b and alpha, I will take that. Okay, I'm going to substitute. So substituting, since this is equation 2, substituting equation 1 into 2, we will be having, okay, alpha squared plus 2 alpha, and for gamma, I will put minus b minus 2 alpha equal to 0. All right. So that's going to give us here, you see that we have alpha squared. And when we multiply 2 alpha times minus 2 alpha, we get minus 4 alpha squared. So alpha squared minus 4 alpha squared is minus 3 alpha squared. And then when we multiply this 2, we will get minus 2b alpha. All right. And that's equal to 0, basically. All right. So this is what we are having. Okay. So from this, I think we can take this a little further. If we factor out alpha, we'll be having minus 3 alpha minus 2b, basically equal to 0, which would mean that here either alpha will be 0 or minus 3 alpha minus 2b is equal to 0. All right. So we can actually make alpha the subject so that we express it in terms of b. So it's going to come out as 2. Actually, it's going to be negative. So that's minus 2b over 3. All right. So this is another important result. Okay. I'll call this 3. All right. All right, let's go on to the very last thing, the fact that alpha beta gamma is equal to minus d. All right, so alpha beta gamma is equal to minus d. But since we've been told that alpha is equal to beta, then what that's going to mean is for beta, I'll put alpha. So it's as good as alpha squared gamma is equal to minus d. But we know what gamma is. All right, so we have and we actually now know what alpha is again. All right. So we are going to say, all right, if I call this equation 4, all right, I will take here equation 1, which is gamma is equal to minus b minus 2 alpha. But for alpha, I'm going to put minus 2b over 3. So basically, we have minus b plus 4b over 3. All right. Now, this will simplify to a third b. All right. So if we then take back the equation 4, for alpha squared, we will have minus 2b over 3 squared. All right. And that's of gamma. Now, gamma is a third b. So that's of a third b. This has to be equal to minus d, basically. All right. So we are going to be having 4b squared times b. So that's going to be 4b cubed over 3 squared is 9, and 9 times 3, that's 27, is equal to minus d. All right, and multiply both sides by 27, we have 4b cubed is equal to minus 27d. Right, I've just multiplied both sides by 27, basically. Right, so if we take minus 27d to the left, we'll be having 4b cubed plus 27d equal to 0. Okay, and that's actually what they want us to show here. All right. So I'll say here, shown. So that's how we do it for part A. Let's go on to part B. On part B, it says, given that 2 alpha squared plus gamma squared is equal to 3b, find the values of b and d. All right. So we have 2 alpha squared plus gamma squared equals to 3b. And I'm going to say that's as good as 2. And for alpha squared, if you recall, we had alpha here as minus 2b over 3. So we can have that here, minus 2b over 3 squared plus gamma. We also had gamma here somewhere, right? Here we had established that gamma was equal to a third b. So we're going to say a third b squared. So this is what we have, right? Let's simplify this. Actually, this is equal to 3b. So simplifying this, we'll be having here 8b squared over 9 plus b squared over 9 is equal to 3b. All right. So that's going to be, if we add this two, we get b squared, and that's equal to 3b. So that's b squared minus 3b is equal to 0. And b factored out is b minus 3 equal to 0. So it's either b is going to be equal to 0 or b minus 3 equal to 0, leading to b being equal to 3. All right. So the correct value of b should be 3 because b cannot be equal to 0. All right. Since we have it as a coefficient of x squared here. So basically B is equal to 3. So that's one of the answers. All right. They also say we should find D. And to find D, if we take the original, actually this equation here, we can have it here. So that's 4b cubed plus 27d equal to 0, which is 4 of 3, actually cubed, plus 27d equal to 0. Okay, so that's equal to 27d is equal to, and for 4 times 3 cubed, that's minus 108. And if we divide both sides by 27, we get d to be minus 4. Okay, so we now have the value of d to be minus 4 and the value of b to be 3. So that's how we do it for this particular question. Let's move on to the next one. All right, question number 2. All right, so on question number 2, they say prove by mathematical induction that for all positive integers n, 7 to the 2n plus 97 to the n minus 50 is divisible by 48. All right, so I'm going to start by saying let P sub n be the proposition that 7 to the 2n plus 97 to the n minus 50 is divisible by 48. So therefore, P sub 1 would be 7 to the 2 of 1 plus 97 to the 1 minus 50. Now, this is as good as 49 minus 97, actually plus 97 minus 50. And this gives us 96. And we know that 96 is divisible by 48. Therefore, the statement P sub 1 is true. Let's go on to the statement P sub k, where we are going to assume that the statement P sub k is true, basically. So we'll be having 7 to the 2k plus 97 to the k minus 50 is divisible by 48. So what that means that it is equal to 48 of, say, L. All right. So basically it's a multiple of 48. Let's go to the statement P sub k plus 1, where we are now proving for n being equal to k plus 1. So it's going to be 7, okay, to the 2 of k plus 1 plus 97 to the k plus 1 minus 50 is equal to, okay, so let's simplify this and see if it is going to come out being divisible by 48 or not, right? So simplifying this, we'll be having 7 to the 2k of 7 to the 2, all right? And that's plus 97 to the k of 97 to the 1 minus 50. All right, so we have 49 of 7 to the 2k plus 97 of 97 to the k minus 50 here. All right, so next, 49 is 48 plus 1, and that's of 7 to the 2k, plus for 97, that's 96 plus 1 of 97 to the k, and that's minus 50. All right. Now, let's take out this product, which is 7 to the 2k, and the product 97 times 1 again. So that's going to be plus 97 to the k. And let's take out the minus 50. So minus 50. And that's going to be plus. What remains is 48 times 7 to the 2k, right? So 48 of 7 to the 2k. And also here, 96 of 97 to the k, all right? So that's 96 of 97 to the k, okay, like this. Now, what we have here is the same as what we had in the assumption. So it's equivalent to 48L, all right? So we're saying that we have 48L plus, now what we have here is something that is, okay, like this, 48 off. If we fade out 48, that is 7 to the 2k, all right, plus 2 times 97 to the k, all right? And if we let here m be equal to the 7 to the 2k plus 2 times 97 to the k, we will therefore be having 48L, right? So 48L plus 48m. Basically, that's 48 of L plus m, which is something that is divisible, obviously, by 48. Therefore, the statement P sub k plus 1 is also coming out to be true. So we can now write down the concluding statement to say that if true, or let me rather say, if the statement P sub k is true, then the statement P sub k plus 1 is also true as proved. And therefore, by the principle of mathematical induction, this has to be true for, okay, we're proving for all positive integers n. So for all positive integers n. So that's how we perform the proof here. Let's move on to the next question. Now we're on question number 3. It says, by considering 2r plus 1 all to the power 3 minus 2r minus 1 to the power 3, use the method of differences to prove that the sum of squares of r to n is equal to a sixth n of n plus 1 of 2n plus 1. All right. So we're going to consider the 2r plus 1 to the power of 3 minus 2r minus 1 to the power of 3, which basically is 2r to the 3 plus 3 of 2r squared plus 3 of 2r plus 1. So I've just done a binomial expansion of this. That's going to be minus, all right, 2r to the 3 minus 3 of 2r squared plus 3 of 2r minus 1. All right. So we have 8r cubed plus 12r squared plus 6r plus 1 minus, now here, 8r cubed plus 12r squared minus 6r plus 1. So we have here 8r cubed minus 8r cubed giving us 0. And so will 6r be added to minus 6r to again give us 0. So what remains is 12r squared plus 12r squared, which is 24r squared, and 1 plus 1, which is 2. So this is what we have in for that. So now we are going to have the sum from r is equal to 1 up to n of terms of the form 2, okay, let me put a square bracket, 2r plus 1 cubed minus 2r minus 1 cubed, all right? And that's going to be, let's start with when r is equal to 1. And when r is equal to 1 here, we will be having 3 cubed, and here minus 1 cubed. And that's going to be plus when r is equal to 2, substituting 2 for r in here, we get 5 cubed minus 3 cubed. Then we go to when r is equal to 3. Okay, let's do r is equal to 3. And substituting it into the whole thing, we will get 7 cubed minus 5 cubed. So this goes on and on and on until when r has a value of n, where we'll be having 2n plus 1 cubed minus 2n minus 1 cubed. All right. So that's what we'll be having. Now, we can see here that these terms add together and they give us 0. And so will 5 cubed and minus 5 cubed. So this one will be eliminated as well. All right. And so will this term here again be eliminated by another similar term, okay, preceding it. So what will remain is minus 1 cubed plus 2n plus 1 cubed. So that's what we'll be having right here, okay? So this is the same as the sum from r is equal to 1 up to n. And since this was simplified to 24r squared plus 2, okay? So we're saying that is equal to minus 1 plus 2n plus 1 cubed, all right? And we're going to say that this is the same as 24 of the sum of squares, okay, plus the sum from r is equal to 1 up to n of 2 being equal to minus 1 plus 2n plus 1 cubed, okay? So that's 24 of the sum of squares plus here, this gives us 2n being equal to minus 1, all right, plus, I think for here, let's just expand 2n plus 1 cubed. And this will give us 8n cubed, all right? And that's going to be plus 12n squared plus 6n plus 1, basically. All right, so we're going to take the 2n to the right. So we are left with 24 of the sum of r squared, r is equal to 1 up to n here, is equal to, also think you can see that minus 1 plus 1 give us 0. So we have 8n cubed plus 12n squared, and that's going to be plus 4n that we have. And we can actually factor out 4n so that we have 2n squared plus 3n plus 1, basically. So that's going to be 4n off. And if we factorize, we will be having 2n here and n, 1 and 1 plus and plus. All right. So that's what we'll be having. And we are going to have that being equal to 24 of the sum from r is equal to 1 up to n of squares. So divide both sides by 24, which eventually will give us the sum from r is equal to 1 up to n of r squared is equal to, now 4 over 24 is a sixth. So we have a sixth of n, and I'll start with this bracket of n plus 1, then this bracket of 2n plus 1. So we now have it, okay? That's now in this particular form. So I'll say, therefore, proved. So that's how we do it. Let's move on to the next question. Now we are on this part, which says, let S sub n be equal to 1 squared plus 3 times 2 squared plus 3 squared plus 3 times 4 squared plus 5 squared plus 3 times 6 squared, and so on, all the way up to 2 plus minus 1 to the n of n squared. So on part B, they say, show that sum to 2n is equal to a third of n of 2n plus 1 of an plus b, where a and b are integers to be determined. All right. So in this particular case, sum to n all right, can be written here in sigma notation as the sum from R is equal to 1 up to n of terms of the form, just taking this form, 2 plus minus 1 to the R, O of R squared, basically. All right. So I've just written the sigma notation for this, right? And the terms here, when R has a value of 1, okay, I want you to look at how the terms are. When R has a value of 1, I think you can see that the first term will be, okay, 1 of 1 here, of 1 squared. And when R has a value of 2, if we put 2 here, it will become 2 plus 1, that's 3. So 3 of 2 squared. When R has a value of 3, all right, if we put a power 3 here, this becomes minus 1. So that's just 1 of 3 squared. Lastly, maybe when R has a value of 4, that's going to be 3 of 4 squared. So I think you can see here that we have got terms that have a factor of 1 and have a base which is even, and then other terms that have a base that is odd. So technically, since they want us to find sum to 2n, we can say that sum to 2n is equal to, all right, and let's start with the terms which have a factor of 1, okay, and these terms are coming out to be odd, to have odd bases basically. So that's 1 squared plus 3 squared plus 5 squared and so on. So the nth term for the bases, okay, 1, 3, 5 is 2n minus 1 squared. All right, and that's going to be plus. Now we're adding them to these other ones, okay, these types of terms where the base is even. So that's going to be, we factor out 3 of 2 squared, right, plus 4 squared plus 6 squared and so on up to 2n, all right, squared. So it's actually a sum up to 2n, all right? So basically with what we have, I prefer to take it back to sigma notation. So it's one of this series, which is the sum from R is equal to 1 up to n of terms of the form 2r minus 1 all squared plus, for this part, that's 3 of the sum from R is equal to 1 up to n of terms of the form 2r squared, taking it from this form here. All right, so this is what we're having, and we can simplify this. This is equal to the sum from R is equal to 1 up to n. Expanding this, we get 4r squared minus 4r plus 1. All right, this whole thing, and that's plus 3 of the sum from R is equal to 1 up to n of the terms of the form 4r squared. Okay, so we have the sum from R is equal to 1 up to n of terms of the form 4r squared minus the sum from R is equal to 1 to n terms of the form 4r plus the sum from R is equal to 1 to n of 1 plus, here I'll take it as the sum from R is equal to 1 up to n of, that's 12r squared. So these two terms add up to give us 16r squared. So basically we have 16, all right, of the sum of squares, all right, and that's going to be minus 4 of the sum of terms that form R like this, and it's going to be plus n. This is going to be equal to 16 of, and for the sum of squares, we know that that's a sixth of n, all right? It's a sixth of n plus 1 of 2n plus 1. All right. And that's going to be minus 4. And for the sum of terms of the form R, that's a half of n plus 1. And that's going to be plus n. Okay. So this is what we're having. I'm going to create a little bit of space here. All right. So we have here 16 over 6, which is 8 over 3 of n plus 1 of 2n plus 1. And that's minus here becomes 2n of n plus 1 plus n. I'll factor out here a third of n. And if we do, we'll be having here 8 of the product of these two brackets. All right. So the product of these two brackets is 2n squared plus 3n plus 1. And that's going to be minus, if we divide this by a third, n, we get 6 of n plus 1. And dividing this by a third of n, we get plus 3. So we have a third of n off, and here we get 16 n squared. And multiplying this, we get 24n, and 24n minus 6n is 18n. All right. And then 8 times 1 is 8, and 8 minus 6 is 2, and 2 plus 3 is 5. So plus 5. All right. So that's a third of n off. And factorizing this, we get 2n and 8n for this product. And we'll be having 2n here plus 1 and here plus 5, so that this to give us a product of 5. So what we now have is the answer. All right. And if you check back, that's actually the form they want it to be in. So that's basically how we do it here. Let's go on to part C. On part C, they say, state the value of the limit as n approaches infinity of the sum to 2n over n cubed. All right. So we're going to say this is the limit as n approaches infinity of, for sum to 2n, we have this thing here. All right. And I'm going to write it as, okay, in expanded form, like taking a third n into the bracket. So I'll write it as 16 over 3 of n cubed plus a third of n times 18n would be 6n squared, and plus 5 over 3n. And that's all of n cubed. So that is the same as the limit as n approaches infinity of 16 over 3, because they cancel, the n cubes cancel, and it's plus 6 over n plus 5 over n squared, 3n squared basically. So as n approaches infinity, you can see that this would tend towards 0 and this would tend towards 0. And the only thing remaining is 16 over 3. So the answer is 16 over 3. So that's how we answer that part. Let's move on to the next question, number 4. So on question number 4, it says the plane pi contains the line r is equal to 3i minus 2j plus k plus lambda of minus I plus 2j plus k, and r is equal to 4i plus 4j plus 2k plus mu of 3i plus 2j minus k. So on part A, find a Cartesian equation of pi, giving your answer in the form ax plus by plus cz equal to d. All right. So in this particular case, we've got a plane pi, okay, from what's been given. So a plane pi, and it contains these two lines, okay? There's two lines that we've been given, okay? We've been given the equations. So they want us to find the Cartesian equation of that plane. So what we will need to first find is the normal to the plane, all right, n. And for the normal to the plane, we're going to do vector product for the directions of the two vectors. vector lines. So we'll take this, which is -1, 2, 1, and vector product with the direction here, which is 3, 2, and -1. Okay. So what is this going to give us? All right. I'm going to close out this row and I will do -2, -2, okay, which is -4 basically. So we have -4 here. Next, I'll close out the middle. So I will do this product, which is a 1, -3, which is -2. So since it's plus, minus, plus, this will be minus of -2, so it's 2. Then I'll close out this and I'll do this product, -2, -6, which is -8, right? So we have -8. Well, this is proportional to, if we divide all of them by -2, we get 2 minus 1, 4. So we're going to make use of this simplified form of n, okay? So that's what we are having for n. Now, we'll also need to find, d, which is found by a dot n. So basically, a is any point on the plane. We can take any point like this point, okay? That's 3 minus 2, 1 dot n, which we got here, 2 minus 1, 4. So the dot product is going to be 3 times 2, that's 6, plus -2 times -1, that's 2, and 1 times 4, that's 4. So that gives us what? 12. So the vector equation will be r dot n, 2 minus 1, 4 is equal to 12. But the Cartesian equation required is going to be 2x minus y plus 4z is equal to 12. So that's the answer right here. All right, let's go on to the next part, part B. They say the line L passes through the point P with position vector 2i plus 3j plus k and is parallel to the vector j plus k. So on part B, find the acute angle between L and pi. All right. So we need to find the equations first. The equation of the line L, they say that it passes through this point. So I'll say its r is equal to 2, 3, 1. And it's parallel to this. So j plus k is the direction vector. So I'll say plus s of 0, 1, 1. Okay. Now, then pi is like the equation we got earlier. Okay. I'll just take this form of it. Okay. So I'll paste it down here. So these are the two things that we have. And since we're looking for the acute angle between L and pi, I'm just going to say sine theta is equal to b dot n over mod b mod n. And this will give us the acute angle. All right. So sine of theta is equal to b dot n. Okay. B is the direction vector here. 0, 1, 1 dot n is this. Okay. 2 minus 1, 4. And that's going to be over, all right, the modulus of, for 0, 1, 1, is the square root of 1 squared plus 1, 1 squared. That's √2. And the modulus of this factor is the root of the squares. So 4 plus 1 plus 16, which is 21. So that's √21. So basically, it's going to be equal to, for the dot product on top, that's like 0 minus 1 plus 4, which is 3, over the denominator will become √42, right? So theta is arcsine of 3 over √42, which would give us, if we type this in, 27.6 degrees. So 27.6 degrees is the answer to part B. Let's move on to the next part. Part C, find the position vector of the foot of the perpendicular from P to pi. All right. The plane we have, that's the plane pi. Okay, say this is the plane pi. I think I'll draw it in a better way. Even this way is better, I think. Right, so this is the plane pi. Okay, I'll just call this pi. And we have a point P. So from P, we want the foot of the perpendicular, which is this point, basically, the point Q. So we want the position vector of Q. That's what they want us to find. So Q is the foot of the perpendicular from P to the plane pi. Now, what do we have? The point P has position vector 2, 3, 1, right? So this is the point 2, 3, 1. All right. The equation of the plane pi we have again. All right. And I'm going to make use of this. All right. So that is the equation of the plane pi. All right. Okay, let me just place it by here. Okay. So we have everything we need. Right. So what we're going to do is we're going to find the equation of the PQ, all right? And for that, we'll say that it's R is equal to the point 2, 3, 1 plus T of the direction vector of PQ. PQ has the same direction vector as the normal to the plane, right? So, well, 2 minus 1, 4. So what that means is that the point Q should have should be 2 plus 2t, 3 minus t, 1 plus 4t. All right. So that's the point Q. And with this, we also know that since we have the equation R dot 2 minus 1, 4 being equal to 12. For R, we can use any point on the plane, right? For R. And Q is a point on the plane. So it also follows that 2 plus 2t, 3 minus t, 1 plus 4t dot 2 minus 1, 4 should be equal to 12. Okay. So we have 2 of 2 plus 2t minus 1 of 3 minus t plus 4 of 1 plus 4t being equal to 12. That's 4 plus 4t minus 3 plus t. All right. It's plus t plus 4 plus 16t equals to 12. Now, 4t plus t plus 16t is 21t. Then 4 minus 3, that's 1, plus 4, that's 5. So plus 5 is equal to 12. All right. So that means that 21t is equal to what? 7. So t is equal to 7 over 21, which is essentially a third. Okay. So since t is a third, we can therefore say that the foot of the perpendicular required is actually OQ. Okay, that's what we said, right? And that's going to be what for OQ? Remember, OQ is this, and we're substituting here a third for T. So let me just take this. All right. And I'll just place it here. So since T is a third, we will be having 2 plus 2 of a third, which is 8 over 3. 3 minus a third, which is, again, 8 over 3. And 1 plus 4 over third is 7 over 3. So we can factor out a third, basically, and we have 8, 8, 7 like this. This is the answer, and that's how we do it. Let's move on to the next question. Now we're on question number 5. It says the matrix M is given by M is equal to half root 2 minus half root 2, half root 2, and half root 2 of 1K01, where K is a constant. So on part A, the matrix M represents a sequence of two geometrical transformations. State the type of each transformation and make clear the order in which they are applied. Okay. So let's work on this, all right? We know that when you have two matrices here representing a transformation, it means that the transformation are going in the reverse order. So the first transformation is actually this one, and this one is the second transformation. So let's start with the first transformation, represented by 1K01. Okay. So if you know these matrices by head, you can, produce the answer. But what if you've forgotten, right? That's when you're going to go manual. Okay. You're going to consider an XY plane, and you start with the point 1, 0. So the point 1, 0 gives you the image corresponding to this. So in this case, 1, 0 gives us 1, 0, which tells us that the x-axis basically is invariant. So x-axis invariant, that's what we are concluding here. Then we also consider the point 0, 1. Okay, let me write it on the left. Right, so the point 0, 1. So the point 0, 1 corresponds to K1, gives us K1. All right. K1 is a point somewhere, maybe here. All right. So, well, if you look at it, you can see that, let's say we were considering this to be a unit square. It's apparent that we will be having something like this for the image. All right. So what's basically happening is some kind of a shear. It's actually a shear. So the transformation is a shear, okay, parallel to x-axis. Actually, the x-axis is invariant. So x-axis invariant, and with the vector of k. So that's basically what's happening. That's the first transformation. The second transformation is represented by the matrix given, all right? That's the matrix, a half root 2 minus a half root 2, a half root 2, and a half root 2. Okay, so for some of you students, you already know that we're dealing with the rotation here, right? But well, just to make everything clear, this is y, this is x, right? We have a point here, the point 1, 0. So 1, 0 is being mapped onto the point this, okay? A half root 2, a half root 2, right? Which is a point, say, here. So basically what's happening is from the line that goes here, it's like we're moving to another point here, which has coordinates a half root 2, a half root 2, right? So there's an angle here responsible for this, which is the angle alpha, okay? And considering that this is a half root 2 and a half root 2, so we can say that alpha is arctan of a half root 2 over a half root 2. So it's arctan 1, which essentially is like 45 degrees. So we can say that what's happening is a rotation, all right, with the center, the origin, and by 45 degrees anti-clockwise. So that's basically what's going on here. Let's move on, all right? Now we're on part B. Part B says, triangle ABC in the XY plane is transformed by M onto triangle DEF. Find in terms of K the single matrix which transforms triangle DEF onto triangle ABC. Right, so we have triangle ABC and triangle DEF. So through the matrix M, we can transform ABC onto DEF. But now they're talking about the single matrix which would do the reverse basically. So triangle DEF to triangle ABC. So it has to be M inverse that we're looking for. But let's start with M, okay? For the matrix M, we have half root 2, half root 2. That's what I can still recall. And what else do we have? Minus half root 2. Okay, so minus a half root 2 and a half root 2. Then the other matrix is 1K01, okay? 1K01. So for this product, okay, for this product, we have here, if we do row and column, we will be having a half root 2, all right? And row and column will give us a half root 2 of K minus a half root 2. All right. Then row and column will give us, there's a 2 here, a half root 2. Then this row and this column will give us a half root 2 of K plus a half root 2. So we have this as a half root 2 and a half root 2 of K minus 1. A half root 2 and a half root 2 of K plus 1. So this is what we are having here. So we will need to know what the determinant of M is. All right. The determinant is this product, which is a half root 2 of a half root 2 of K plus 1 minus this a half root 2 of a half root 2 of K minus 1, right? So we have a half root 2 times a half root 2 would give us a half. So we have a half of K plus 1, which is half K plus a half. And that's minus here. If we multiply this 2, it's again a half. And a half times K minus 1 would be a half K minus a half. All right. But since there's another minus here, this actually becomes plus. And half K minus half K is 0. And a half plus a half is 1. So that's the determinant. So for M inverse, we will be having here, if we go back to the matrix M, we will switch positions for these two. And we will be having here a half root 2 of K plus 1. And here, a half root 2. And for this one here and this one here, they will simply change sign. So we'll be having minus a half of root 2 of K minus 1 and minus a half of root 2. So this is the matrix we are looking for. Okay, and that's how we do it. Let's move on. Now we're on part C. In part C, it says, find the set of values of K for which the transformation represented by M has no infrared lines through the origin. All right, so here we're going to take the matrix M, okay? The matrix M is what we have right here. I'm just going to remove this. So this here is the matrix M. So I'm placing it down here. So we have the matrix M here. And if we multiply points X, Y, we normally expect to get the image X dash, Y dash. All right. So row and column will be having half root 2 of X plus half root 2 of K minus 1 of Y is equal to X dash, and half root 2 of X plus half root 2 of K plus 1 of Y is equal to Y dash. All right. So this is what we are having right here. All right. So we're going to say now, if the lines are, or let me say were, if the lines were invariant through the origin, we know that y would be equal to mx. So where there is y, we can put mx. So we'll be having half root 2 of x plus half root 2 of k minus 1 of mx equals to x dash, and half root 2 of x plus half root 2 of k plus 1 of mx is equal to y dash. All right. It also means that the image lines will also be invariant through the origin. Okay, in the event that the lines were invariant, okay, originally. So we would therefore say, so therefore y dash would be equal to mx dash. So y dash is half root 2 of x plus half root 2 of k plus 1 of mx is equal to m of x dash, which is half root 2 of x plus half root 2 of k minus 1 of mx. All right, like this. So this is the relationship we'll be having. Okay, now you can see that all the terms have got x. So we're going to divide x out, and we will be left with half root 2 plus here half root 2 of m of k plus 1 is equal to, and I'll multiply m into the bracket here. So it'll be half root 2 of m plus half root 2 of m squared of k minus 1. All right, let's continue simplifying. So we have here half root 2 plus half root 2 of km plus half root 2 of m. I've expanded the brackets here. All right. Let me move this to the left a little. So this is equal to half root 2 of m plus half root 2 m squared. So that's going to be km squared. And that's going to be minus half root 2 of m squared. Okay. Now, if we subtract half root 2 of m from both sides, okay, it gets eliminated. Now, for what remains, I'll factor out half root 2 on the left, and we'll be having 1 plus km. And on the right side, I'll also factor out half root 2, and we'll be having km squared, and that's minus m squared. Okay, that's what we are having here. All right, and these two will cancel. So we have 1 plus km is equal to km squared minus m squared. For these two, we can factor out actually m squared. So basically we have k minus 1 of m squared, is 0 here, minus km minus 1. So that's the equation we will be having. Okay, can rewrite it as k minus 1 m squared minus km minus 1 equal to 0. So remember, the question is saying that we have to find the set of values for which the transformation has no invariant lines through the origin. So we are saying here, for no invariant lines through the origin, b squared minus 4ac should be less than 0, basically. All right. So that's going to be here. We know that A is k minus 1, B is minus k, and C is minus 1. So B squared minus 4AC will be minus k squared minus 4 of k minus 1 of minus 1. So this becomes a plus, and that has to be less than 0, right? So that's going to be k squared plus 4k minus 4 is less than 0, okay? And for the critical values, I'm going to solve the equation k squared plus 4k minus 4 equal to 0. And using the calculator, okay, for this working, we will get the values of k to be minus 2 plus or minus 2 root 2. All right. So it's like we have here, since k, the coefficient is positive, so it's a U-shaped parabola. This here is minus 2 minus 2 root 2, and this one is minus 2 plus 2 root 2, and this is k, right? And less than 0 means values for which it is below the k-axis here, which are values from minus 2 minus 2 root 2 to minus 2 plus 2 root 2. So this is the answer. These are the set of values of k for which the lines, actually for which there are no inferring lines through the origin. So that's how we do it for this question here. Let's move on to number 6. Well, number 6, the question says, show that the curve with Cartesian equation x squared plus y squared all squared is equal to 36 of x squared minus y squared has polar equation r squared is equal to 36 cos 2 theta. All right. Okay, so what we know is that r squared is equal to x squared plus y squared. We also know that x is equal to r cos theta, and we know that y is equal to r sine theta. So with that knowledge, we can therefore say for x squared plus y squared, we can say that's r squared squared equals to 36 of, for x squared, that's r squared cos squared theta minus, for y squared, r squared sine squared theta. All right. So that's r to the 4 is equal to 36 r squared of cos squared theta minus sine squared theta. Now we're going to make use of the trig identity for cos squared theta minus sine squared theta. So that's r to the 4 is equal to 36 r squared. And then for this, that's cos 2 theta. All right. And that's what we're having, right? Let's divide both sides by r squared. So this side by r squared, this whole side by r squared. So eventually we'll be having r squared being equal to, here they cancel, 36 cos 2 theta, okay? Which is the same thing they want us to show here. That's shown. Let's move on to the next part. Now in part B, they say the curve C has polar equation r squared is equal to 36 cos 2 theta for values of theta ranging between minus a quarter pi to a quarter pi. So sketch C and state the maximum distance of a point on C from the pole. All right, so here we're going to consider a polar plane. And on this polar plane, the range of values we've been told that it's from minus a quarter pi to a quarter pi. All right. So we're going to make a small table of values, and we're going to have intervals of an eighth pi. So we will have values of theta minus a quarter pi minus an eighth pi, 0, an eighth pi, and a quarter pi. So when theta is minus a quarter pi, r is 0, substituting it into the equation. When theta is minus an eighth pi, r is 5.0. When theta is equal to 0, r will be 6. When theta is an eighth pi, r will be 5.0. And when theta is a quarter pi, r will be 0. So we can plot out the points here, and you can see the curve comes out like this. All right, so putting the curve here, we have the initial line here, theta is equal to 0, and the pole here. And you saw that the curve came out like this. Now, they also say that we should state the maximum distance of a point on C from the pole. So the maximum point of a point on C from the pole is this point here. So that's when theta is equal to 0. And if we go back on the table of values, we saw that when theta is 0, r is 6. So therefore, the maximum distance required is equal to 6. All right, let's move on to the next part. Find the area of the region enclosed by C. Right, so the original equation is r squared is equal to 36 cos 2 theta. And for the area, it will be half of the integral from minus a quarter pi to a quarter pi of 36, because that's r squared, 36 cos 2 theta with respect to theta. So that's going to be half of 36 is 18. And integrating cos 2 theta, we get a half of sine of 2 theta. And that's minus a quarter pi and a quarter pi on top. Okay. Now, this is going to be equal to 18. Actually, half of 18 is 9. So 9 of sine, okay? Here, sine of 2 of a quarter pi. That's like sine of a half pi. So sine of a half pi. And that's going to be minus of sine of 2 times minus a quarter pi. So minus and minus becomes a plus. So sine of a half pi again. And sine of a half pi is 1. So it's like we have 9 of 1 plus 1. So we get the answer as 18. That's the answer. Let's go on to part D. On part D, they say, find the maximum distance of a point on C from the initial line, giving the answer in exact form. All right. So the key part is the maximum distance of a point on C from the initial line. Now, for the maximum distance of a point on C from the initial line, we know that, okay, let me just write that down. Okay, so we know that for maximum distance from initial line, dy by d theta should be equal to 0. So in this particular case, we have the equation r squared is equal to 36 cos 2 theta. All right. And we also know that y is r sine theta, leading to r being equal to y over sine theta. Therefore, r squared can be written as y squared over sine squared theta, being equal to 36 cos 2 theta. All right. Let's multiply both sides by sine squared theta. So y squared is equal to 36 cos 2 theta sine squared theta. Let's square root both sides. So that means that y will be equal to 6, and that's going to be cos of a half of 2 theta sine theta, like this. So we can now find dy by the theta. We do the product rule. So I'll take 6 sine theta times the derivative with respect to theta of cos to the half of 2 theta plus cos to the half of 2 theta times the derivative with respect to theta of 6 sine theta. Okay, so that's going to be 6 sine theta off. Now differentiating this by the chain rule, we will bring down the half, then differentiate cos 2 theta. Okay, which gives us 2 sine, actually it's minus, okay? So it's minus 2 sine 2 theta. And that's going to be of the cos to the half theta, but the power is half to the power minus 1. So it becomes cos to the minus of a half of 2 theta. Okay, so that's going to be plus on this part, that's cos to the half of 2 theta. And differentiating 6 sine theta, we get 6 cos theta. Well, all this has to be equal to 0, okay? Because dy by the theta is equal to 0, right? So we have on here, okay, these two divide into each other, we get 1. So we have minus 6 sine theta of sine 2 theta of cos to the minus of half of theta. So I'll put it at the bottom, okay? So cos to the half of 2 theta, and that's plus on this part, that's just cos to the half of 2 theta. Actually, there's a 6 and of cos theta, all equal to 0, okay? So I'll multiply all the terms by cos to the half of 2 theta. So we have minus 6 sine theta sine 2 theta plus, if it multiplies here, they become cos 2 theta of cos theta equal to 0. Okay, so this is what we're having now. Now, with what we have, I am going to divide all the terms, okay? Let's divide everything by 6. Okay, let me say minus 6 cos 2 theta cos theta, even here, by minus 6 cos 2 theta cos theta, even on the right side, minus 6 cos 2 theta cos theta. And when we do, we will be having here, that will be like for sine over cos, that's tan theta. So we have tan theta, because these will cancel, and sine 2 theta over cos 2 theta is tan 2 theta. Here we'll be having minus 1 equal to 0. So it's like we have tan theta of, for tan 2 theta, we can use the identity, that's actually 2 tan theta over 1 minus tan squared theta. And I'll take the minus 1 to the right, so it's equal to 1. So basically, we have, if we multiply both sides by 1 minus tan squared theta, we'll be having 2 tan squared theta is equal to 1 minus tan squared theta. All right. So now, if we take minus tan squared theta to the left, it's 3 tan squared theta is equal to 1. So tan squared theta is equal to a third, which leads to tan theta being equal to plus or minus 1 over root 3. All right. Now, arctan, okay, arctan of 1 over root 3 is a 6th pi. Now, we will take only 2 possible values of theta, that is plus or minus a 6th pi. Now, when, okay, because the question requires us to find the maximum distance. So if we substitute, okay, a 6th pi for theta into here, we will get 3 root 2 over 2. So basically, we are saying that when theta is a 6th pi, y will come out as 3 root 2 over 2. So that's the maximum distance, basically. That's the answer right here. Let's move on to the very last question in this paper. On number 7, the question says, the curve C has equation y is equal to 5x squared over 5x minus 2. So in part A, find the equations of the asymptotes of C. All right, so we start with the vertical asymptote, which we find by equating the denominator to 0. So it's x is equal to 2/5. But we also have an oblique asymptote, since the degree of the numerator is greater than the degree of the denominator. And we find it by division, right? 5x minus 2, we divide it into 5x squared. Okay, so 5x squared divided by 5x gives us x, right? And x times this is 5x squared minus 2x. Okay, and we subtract the 2, and we are going to get 5x squared minus 5x squared is 0. Then 0 minus that is just 2x. All right, and we divide, okay, this is plus 0. Okay, so we divide 2x by 5x to get 2/5. 2/5 times this would give us 2x minus 4 over 5, and we will subtract, the remainder is 4/5, right? But what we want, okay, remember this was 2/5. What we want is the quotient x plus 2/5. So therefore, the oblique asymptote is y is equal to x plus 2/5. So we have two asymptotes, this and this. Let's move on. On part B, they say find the coordinates of the stationary points on C. All right. So for the stationary points, we know that dy by dx is 0. So we have y is equal to 5x squared over 5x minus 2. And at stationary point, we know that dy by dx is equal to 0. So therefore, for dy by dx, we'll be having 5x minus 2. I'm doing the quotient rule for differentiation times the derivative with respect to x of 5x squared minus 5x squared times the derivative with respect to x of 5x minus 2. And that's going to be over the denominator. This is going to be equal to 0. Multiply both sides by the denominator. So on top, we'll be having, if we differentiate 5x squared, we get 10x of 5x minus 2. And that's minus, differentiating 5x minus 2, we get 5. 5 of 5x squared, okay, equal to 0. That's what we'll be having. So we have 50x squared minus 20x minus 25x squared equal to 0. So that's 25x squared minus 20 equal to 0. Okay, 20x. And we factor out 5x here. We get 5x minus 4 equal to 0. So it's either x equal to 0 or 5x minus 4 equal to 0, where x comes out as 4/5. All right. So these are the two possible values of x, all right? So we're saying here we have x and y, and x can be 0 or 4/5. All right, when x is 0, substituting that into this equation, we get that y will be 0. So 0 here. And when x is 4/5, we get y to be 8 over 5. So 8 over 5 here. So therefore, the coordinates of the stationary points are 0, 0, and 4/5, 8/5. That's the answer here. Let's move on to the next part. On part C, they say sketch C. Right, so we have the x's. This is the x-axis. And this is the vertical axis we have here. So that's y. And the origin, we have the asymptotes. Okay. X is equal to 2/5. X is equal to 2/5 can be this line here. So we have 2/5 here. Then the other asymptote is an oblique asymptote. Y is equal to x plus 2/5. So it should go like this. All right. like this. So we know that it intercepts the y-axis at 2/5. All right. Now, this type of graph has two turning points, one at 0, 0, and this other one. So what that means is that the graph is like this. All right. And here, turning point at the origin. So this is how the graph is like. All right. Let's move on to part D. Sketch the curve with equation y is equal to mod of 5x squared over 5x minus 2 and find in exact form the set of values of x for which mod of 5x squared over 5x minus 2 is less than 2. Right. All right. So we want to make the graph, a sketch of the graph of the modulus. So I'm going to take the original graph here, and we're going to reflect the part of the graph that is below the x-axis in the x-axis. So we'll be having something like this. Okay, so something like this, all right? And we are going to remove everything that is below the x-axis. All right, so we have 0 here. There was 2/5. So this is basically the modulus graph, okay, like this. And then they say in the question, we should find in exact form the set of values of x for which mod, okay, the modulus graph is less than 2. All right, so we're going to draw the line y is equal to 2, right? Now we're considering here that the turning point had a y value of 8/5, okay, 1 3/5, which means the line y is equal to 2 should be higher than that. So this here is the line y is equal to 2, and it intercepts the graph at several points. It intercepts it at this point and this point, all right? And it also intercepts it at this point and at this point. So we have 4 intercepts basically. All right, so for the first 2 intercepts, okay, let's start with the first 2 intercepts. This one here and this one here. Okay, actually, I'll have again these and this as well. So I'll say this is alpha, this is beta, this is gamma, and this is delta. All right, so let's start with the intercepts with the original piece of the graph. This was from the original function, y is equal to 5x squared over x minus 2. So this is where 5x squared over 5x minus 2 intercepts with the line y is equal to 2. So that's what's going to give us gamma and delta. And for this part, it was reflected, okay, before we had made the modulus graph, this part belonged below the x-axis, but it was reflected. So it's like minus of 5x squared over 5x minus 2, and it intercepts with the line 2, okay? So we're going to find the intercepts this way, all right? For alpha and beta, we will use the reflected one, okay? So it's like here we'll be having minus 5x squared is equal to 2 of 5x minus 2. So that's minus 5x squared is equal to 10x minus 4. So this can be rearranged to 5x squared, okay, plus 10x minus 4 equal to 0. And if we solve this for x using our calculator, we get the possible values of x to be minus 5 plus or minus 3 root 5 all over 5. So that's what we're getting. So these are alpha and beta, basically. So I'm going to do this. I'm gonna move this a little down. So for alpha, we're saying that's gonna be minus 5 minus 3 root 5 all over 5. And for beta, okay, that's gonna be minus 5 plus 3 root 5 over 5. Okay, so that's what we're having for beta here. I'm gonna move this to the left a bit, to the left a bit. Okay, like this. All right, next, to find gamma and delta, okay, where the original graph intersects with the line equal y equal to 2, we have 5x squared equals to 2 or 5x minus 2. So that's 5x squared minus 10x plus 4 equal to 0. All right, and if we solve this for x, we get 5 plus or minus root 5 over 5. So the smaller one, okay, that's 5 minus root 5 over 5, and delta 5 plus root 5 over 5. Okay. Now to solve the equation, okay, because actually the inequality, it's where the modulus graph is less than 2. In other words, where it is vertically below 2. Okay. The graph y is equal to 2. So the graph y is equal to 2 is this one. And the modulus graph is less or vertically below it for these values of x. Okay, for this part of the graph, it is below. I think you can see that. And also this part as well, the graph is below. So these are values between alpha and beta. Okay, so we're saying for our solution, minus 5 minus 3 root 5 over 5 to minus 5 plus 3 root 5 over 5. Union, we also have the other part, that's gamma to delta, which is 5 minus root 5 over 5 to 5 plus root 5 over 5. So this is the solution set, and that's the answer we get for this particular question. No more other question, so we are done. Thank you so much for joining this class, and goodbye.